So let's go ahead. All right. All right. So yeah, my name is Bishop Zara, and I wanted to give this presentation. The kind of the impetus for the presentation was just what uh, Jeff was just saying. The CTO of my company came to me and said, "Please find out how to replace yourself." And I worked on that for about 2 months, and then they fired me. So I guess I did a good job. But it was a research project, and after I got laid off, I continued to continue my research into it. Yeah, so who am I? Bishop Zara. I wrote this website. Some of the things on the website we'll talk about. One of the last project that I did was this website called Matter, and one of the articles that we published on the Matter website. There's the title. AI won't take your job, but someone who uses AI will. And that's kind of going to be a theme, I think, for the presentation. You know, everybody's afraid that this is going to take our jobs. It's not, but it is going to become an essential part of what we do as software engineers. So that's kind of what we wanted to look at. And okay, yeah. So before we jump into a bunch of specifics, I wanted to identify a couple common themes that we're going to look at that'll kind of pop up over and over again. AI was not going to take your job, but someone who uses AI will. Room for failure. This is really important. When looking at different AI solutions, one thing that we want to look for is where is there room for failure? If we are asking the AI to do a perfect job and there is no room for failure, it's not going to do very good. Whereas if we're looking at something that already has a lot of failure in it, AI can help us reduce the amount of failure that's already there. It's this broken Wi-Fi problem. Many years ago, Wi-Fi was just being introduced onto airplanes. The stewardess gets on the announcement, says, "Hey, we have this new feature. You're now going to be able to purchase Wi-Fi on the airplane. Unfortunately, today it's broken." And there's this groan across all the passengers on the airplane, right? They didn't even know that they had this capability. But as soon as it's like, oh, not available today, they're like, oh. It's this expectation that once we see a new technology, we immediately expect it to be perfect. And none of this stuff is perfect. So where does AI work really well? It works well where there's room for failure. And we want to give it more chance than Wi-Fi on an airplane. We want to give it a little bit of a chance to develop itself. Now, while it does that, one thing that we want to look at is ecosystems that surround each of these products and how much vendor lock-in. Vercel is one of the vendors that we're going to talk about. Next.js is a great product. It's a great platform that allows us to build things, but it also locks us into Next.js and Vercel's way of doing things. So that's always a question of vendor lock-in. How much do we want to be locked into a particular vendor? And then I wanted to introduce this concept of one-directional versus two-directional workflows. I think most of us as engineers use two-directional workflows. A two-directional workflow would be just how we work now. A designer designs something, we build it. Then the designer adds a feature, we add the feature to our code. Whatever the designer does, it doesn't prevent us as engineers from doing what we want to do. But a one-directional workflow is just that. The designer designs it once, the engineer builds something out of it, but then if the designer makes any changes, you can't get it back through the pipe. It is one direction. It goes from design to engineering, and then it is totally an engineering line. That's not used very often, but it does have its place in technology. There's lots of solutions that use a one-directional workflow. Some of these tools are really good at it. And then there is this new role that is being created as kind of part of a lot of these tools, and that's the role of a technical artist. This was primarily started by low-code tools, where instead of hiring an engineer that is very expensive, they can hire a junior engineer that needs to write just a tiny bit of code, but can leverage these drag-and-drop style interfaces to build what they need to build. That is a different tool set than we usually use, but if you come out of a boot camp and you can't find a job, maybe a technical artist is a good opportunity, because that's a new thing that's coming up. You need a little bit of creative skills, a little bit of programming skills, and you get paid less. But a technical artist makes bad code. But does it matter? this question is going to come up again and again. Does bad code matter? We're engineers. We want to write good code. Do we have to? Does the code have to be good? And I don't know that I can provide an answer to that question right now. But just to provide some subtlety around it, when we say that code is broken, well, that's bad. You know, if it functionally doesn't do what it's supposed to do, that's bad code. That's not quite always what we mean by bad code. Sometimes we just mean it's not pretty. It doesn't look good. So is that really important? Is it important for it to look all nice? I don't know. I use ESLint because I like my code to look nice. But so these are just some of the questions that have kind of come up along the way. Any thoughts, questions, comments? That was a little introductory hand wave. All right. So part one, my journey. I wanted to take you guys through these technologies in the same way that I was introduced to them. So for me, started with Sushi Dragon. Let me refresh that. So from the beginning. I don't know if you guys have seen Sushi Dragon. He's a Twitch streamer. And he does all these great things. Like, that's him, but then this is what people actually see. He's doing real-time modifications. He uses some AI tools. He uses a program called Hutch Designer to do this stuff. He's a streamer. I enjoy watching it. He went to South by Southwest 2024, and I was in Austin, but I couldn't go. But I got to watch him as he live streamed the whole festival. So I thought that was neat. And at that festival, the thing that everyone kept talking about, the big news from South by Southwest 2024 this year was Devin, the first AI software engineer. What is that? What is an AI software engineer? I mean, isn't that just Copilot? Copilot, made by Microsoft, runs in VS Code, and restart the example. But yeah, you're typing some code, and then you want to ask it some questions, and you can just, write the unit test for this function, and it's going to write some code for you. Isn't that AI software engineering? And in fact, no, it's not. Devin is significantly different than Copilot. The big difference is that Copilot is AI-assisted software engineering, which is where we have a large language model, but it doesn't actually type in the code. While the large language model spit out some code, it is still up to the human to figure out how to integrate that code into your code base. And AI software engineering is different. Devin writes PRs. It writes a pull request. And so then apparently it's really good at passing this, the SWE bench. So what is a benchmark in general? This is a screenshot from the Claude website when Google first released Claude 3. It's along the left-hand side. They're listing off all of these different benchmarks and how does Claude 3 match up to other large language models. So this is how we're judging large language models right now, is how well they perform on these benchmarks. And so you can see undergraduate level knowledge, graduate level reasoning. There's tons of them about math. It's grade school math. It's like 95%. It's pretty good. And that's better than it used to be for other ones. So this is how these models are judging themselves against each other. Introducing SWE Bench. This is a benchmark for not AI-assisted software engineering, but AI software engineering, generative programming. So the way that SWE Bench works, it's based on a certain number of real-world GitHub issues. Has the issue, has the description of the issue, has the entire code base. It writes a PR, and then a series of tests, unit tests and integration tests are run against the PR to see if anything broke that wasn't broken before, and the things that were broken that the PR is supposed to address are suddenly fixed. So let's see here. Claude came in at 13%. And Devin, the AI software engineer, came in at 13%. And that was, as of South by Southwest last March, that was the best anyone had ever done. Prior to Devin, the best model had gotten to 4%. Now, since that time, a few more have come up. Notice Amazon's Q. This is like Amazon's version of Copilot. Now you can notice these are unverified and they're not open source. So there's 3 more closed source models that are getting 13, 14, up to 19%. So while 19% is still not very impressive, that means 19% of the time it's able to correctly solve a real world engineering problem. And the other 80% of the time it's not. That their PR doesn't work. So 19% is not very good, but the fact that it went from 4% to 19% in 3 months is fairly impressive. Some of the criticisms of the SWE bench is that it works only on certain GitHub repositories that are well documented and where the issues are very well written. And if you put it at an issue that is not well written, doesn't have a good description, it's not going to do as well. But this was meant to be an easy benchmark for software engineering. It's not the first, but it was meant to be a really easy one because the other ones are too hard. So they made it as easy as they could. And you can see that we're starting to get up to higher and higher percentages. Now, this was based on a PDF. You can notice the URL here, arxiv.org. It's like a clearinghouse for academic PDFs. If you do want to pursue the stuff, learn about the stuff, these PDFs are where all the new information is published. You can see this was published on April 5th, and it was SWE Bench. And so you read through this, and it explains what they did, and then they built a model that goes against the bench and was able to solve it at the same step, 13%. That one is SWE agent. And so after creating the benchmark, they then made an agent. This one is also open source, unlike Devin, which is closed source, and also gets a 13%. So great. Good job. Good job. What is SWE? The problem is that this doesn't really scratch the itch. While this technology might be getting slightly better, the benchmark is super soft, and we can still only do it at 20%. And yes, pace is increasing, but this is not going to change. It's not going to replace us anytime soon. We're going to have much more difficult benchmarks, and eventually we're going to have numbers like 80% and 79%, not 19%. So this is a slow-moving train that is coming at us. This software agent AI development. But it's not there yet. So if not that, then what? Well, there's the dream. This is what the CTO came to me and asked me about when he said, replace yourself. There is a dream that you can have just a picture of a website, you press a button, and then you have a website, a fully functioning website. That's the dream. That's what all of these CTOs are talking about. Can an AI go directly from design to code? Introducing the design to code benchmark. This is the first design to code benchmark, as far as I know. And of all the other papers despite that it's got Google, Microsoft, Stanford, and Georgia Tech on it, I don't think this PDF is very well written. This is super soft. Let me show you just how soft this is. On page 12 here. So the web page on the left was the original. This is the picture that they provided. And then these two are what 2 different methods came up with as the outputted web page. And then what they asked was they asked a whole bunch of people. They said, well, they give them the reference, and then they give them the output, and they'd say, is the output a good enough representation of the original? And a lot of people say yes. Yeah, it's good enough. It's close. That's close enough, right? Well, in the world we live in, there is no room for failure when it comes to designs. We are expected to deliver pixel perfect. Like 1 pixel off, and we're wrong. There's no room for failure for us. And so there's not really any room for failure for this either. Like, this is not good enough in terms of what we do. So first benchmark, we still don't have any models that even even come close to doing well on this super soft bench. So again, design to code is really far away. I mean, we're just not going to be able to make design. You click one button and you get code. That's just not in the realm of possibility right now. So what is in the realm of possibility? Well, here's Locify, powered by AI, and you go from design to code in one click. Well, isn't that what I just said we can't do? Well, here's a product that says that they're doing it. So what is this about? If not, then what? Well, let's look at Locify. So Locify is a Figma plugin. Figma here. Here's select a page, plugins, and open the Locify plugin. Open, and I've already scanned this page, so it's going to go ahead and rescan. So it goes through and it scans the page. This is apparently where AI is working, right? It's doing all this stuff. Now it's generating previews for us. Great. And it has on the right-hand side here all of these steps that it went through to generate this code with one click. And I look here, when I look at this, I'm like, okay, this is fairly reasonable looking. Try and zoom in on it a little bit. Fairly reasonable looking React code. And it made everything into these separate components. Now, I see a lot of divs with class names. I try to be a lot more semantic in my code. I think that builds a better document structure, makes it more accessible. We don't see those kind of best practices being used here. And then we look at the CSS. And there's 150 lines of it. Well, and then another 250 lines. That's another 50. I did a comparison in a page that I was able to describe in 100 lines of CSS. This generated over 2,000 lines of CSS to generate the same thing. So I guess the two critiques that we're leveling here is that the code isn't exactly the way we'd like it to be, and the CSS isn't exactly the way we'd like it to be. Yes, we have all of these tools over here to control how it goes from the Figma file to the code. But there's going to be limitations. And then what this tool wants you to do is use their CI/CD pipeline to publish the code. So you're supposed to go right from Locify right to a published server. And if you do that, if you're fully bought in, locked into their vendor ecosystem, then it is a two-directional system. Like people can make changes in the Figma file that would be updated in your code, and then you could redeploy and have the changes. This is also where a technical artist comes in. Like nothing that we do over on this right-hand side has anything to do with programming. So it's a different skill set. This is a new skill set where you don't need to know much about the code. You just really need to know a lot about the program that's generating it. So it doesn't have quite as good code as we want, maybe a little bit too much, but it's interesting. Now, if we don't want to deploy to their servers, if we want to take this code and then make additional modifications to it and deploy it ourselves, then if any changes are made in the Figma file, you get two different sets of code, the stuff with the new Figma stuff and the stuff with your changes. And there's no way to merge those together. So then this becomes only a one-directional tool. And if you're just trying to pump out a website and you're not going to make changes to it in the future, like if you have to do 100 and they're all the same website with a different logo on it, like this might be a really good tool for just that one direction. Just get it all out the door, get it all up online. And then if somebody wants to make changes later, that's their problem. So there are uses for something like this, but is this going to replace us? No. And is this really designed to code in one click? No. So where is the AI in this? They say that the AI is in developing this code, but it's pretty clear because AIs don't generate the exact same thing every single time. And yet if I rerun the scan, I get exactly the same set of code. So the theory is that their AI is going from Figma representation to some kind of symbolic representation, and then that is then translated into code. That way they can use their components and their CSS to make sure that everything is done in a consistent way, So that's interesting. It's low code, technical artist. Can be either one directional or two, but you have to have a lot of vendor lock-in to do two. And does bad code matter again? Like, yeah, it's not perfect React, but it made a bunch of it really nice. So maybe that's better in some circumstances. Oh. Another one. This is VO, made by Vercel. The idea is that this is not design to code. This is text to code. So whereas the last example cut out the engineer, you still needed the designers to make the Figma file. Then it just cut out the engineer, replaced them with a technical artist. This cuts out the designer as well. So you're going all the way from just a text description all the way to code. Again, something we said wasn't even possible. A few examples here. So here's the prompt, create me a landing page for a job posting board with a nav bar and sign in direction. Make this. And it has a few variants. All look about the same, really. And then you can go over here and access the code. Now this, it's called V0 because it's supposed to be iterative. So the idea is that you feed in this prompt and you get this one as a result. But then you can say, starting from this one, feed in a new prompt. Okay, now add a footer that has a on it. And so you can continue to iterate to get it closer and closer to the design that you want. So this I could see being really useful if you don't have a designer. If you're an engineer, you're just working on your own website or a prototype or something, this cuts the designer right out of the process. Is it going to be as good as a designer? No. But that's where there's room for failure. You're a terrible designer. Most of us engineers are mostly terrible designers. So AI design is actually going to be better than an engineer doing the design. Is it ever going to be as good as a designer doing the design? Not yet. It has to be the room for failure. Now, a couple of things to note about their code. You get a lot of the same stuff. I'm seeing a lot of class names here. Seeing a lot of these like custom CSS classes. And then I'm seeing like briefcase icon as a component. Then where does that even come from? I don't know. Then there's all these imported ones, card, badge, avatar, etc. And they're not listed here. So while it gives you a copy code button, it doesn't give you all the components. So you can't actually get the code out of this web interface. What you're supposed to do is go to command line and run this command. And when you do, you get a component that looks something like this, which is the same thing we were just seeing in the interface, but you can see now that all of these linked components are here as well. And when we look at those, they're using Tailwind. Not horrible. These are all copies of a design system. So there is a design system, I forget the exact name of it, but all of these base classes, like input and buttons and stuff, all come from that design system. Transient. Say again?
It's a transient. It's transient. I think. Yeah, transient.
And they're pretty clear about where the components come from and stuff. It's all licensed. So you can use those. And I guess for me, I can see this if I'm using a design system, well, it's also going to have a link. So maybe I could use this stuff and then slowly migrate it from their design system to mine. Maybe fine. Maybe I just want to use their design system. That would be okay too. And if as long as I'm happy with all of their CSS stuff, it gets all Tailwind. So it's going to be really concise. So this is not horrible, but again, the code isn't really written the way that I want it written. It's not as semantic as I'd like it to be. It uses a lot of divs, things like that. But if you use this npx command, you can get this code back out, and then you can start to integrate. Now, again, there's this one-directional versus two-directional thing, though. If you get the export from V0, and then you start changing it, it can't go back to V0 and change it there. That's a one-directional transformation. Now, what Vercel wants you to do, vendor lock-in. They want you to host on Vercel and keep this as a two-directional so that you're always just working with VO and the code just goes to the server. But then that doesn't allow us as engineers to improve the code. We have to be happy with what it gives us. Does bad code matter? Is this good enough? Maybe it is. Depends on the project, I suppose.
Do you know what the token limit is? These are all.
I do not know. Like how many words can you put in?
Well, I mean, it's just for that context. Like if you keep reprompting it, eventually your first prompt starts to lose meaning. So as you keep working with it, it's going to lose your initial concept and stuff as you go along. This is a problem with all GPTs or LLMs.
Yeah.
There's only so much processing power and memory that these things can operate. I'd be interested to see like that iterative process, how long it takes before you start losing context. That
I would assume that the problem is at least mitigated by the fact that it has the image of what it generated last time. So my guess is that what it's doing is just like Locify. It's going from text description to an image, from an image to a symbolic representation of the website that can then be matched up to code. It knows what a button is, so it puts in the code for a button. So I think it has that symbolic representation to help provide it continuous context to each of your iterations as you iterate on the design. Hopefully it doesn't forget about old stuff. Yeah, it's not perfect, but it's iterative. It's an interesting tool. Again, I think it's good in the fact that if you don't have a designer, it's going to be a better designer than you.
It'd be a great place to start. It's a great place to start and then change things.
It can be a really good place to start. Yeah.
It's like when we were talking earlier about letters from ChatGPT. You never write, but you can then have a scaffold and you go and change everything.
Yeah. Yeah. So the question is it faster to generate this code out of here and then fix the things you don't like, or just write it yourself? And depending on the project, like again, if you're trying to make 100 pages, you need something to go in there and just like lay all the groundwork. That would be super helpful. If you're trying to make one page that's perfect, well, you probably feel like building it yourself. So one last example in this category, Anima. And I'm sorry, my demo is broken. Not Figma. This is a VS Code plugin. And it installs as an icon here on the left-hand side. So when you're in any app, you can provide it a Figma URL. And this isn't going to work because I don't have the paid version of Figma. Sorry. But what it would do is show you a preview of the Figma file in here where you can select elements and then would write code for those elements. So I like this because I've never seen Figma integrated to VS Code. And for me, I work with the Figma stuff a lot. So it's nice to be able to see it right there. Now, their code that they generate has a lot of the same problems that we've seen in the other ones. Lots of divs, not quite exactly the style that I would want. But one important difference is they don't claim to use AI. They go right from Figma to code. They don't need AI for that. You go from Figma to a symbolic representation, from that to code. You don't need AI. So they're not hand-waving around where the AI is. So their idea was very different than the other two that we looked at. What they said is, if you ask 100 engineers what the right way to write code is, you're going to get 100 different answers. So this idea that we're going to have one tool that's going to write perfect code for everyone is never going to work. What we need is for the tool to understand what your code base looks like already, and then write you code that looks like your existing code. And so with this, once this shows up over here on the left-hand side, you can click Join Beta. It then ingests your entire code base, trains an AI on your code, and then the generated code down here is then generated by that trained language model. So I thought that was a really good idea, because in terms of room for failure, like if it gets close to what I want it to do, that's better. Like that's just going to be better. If it just can even get close, then that's less things that I need to manually change about the code that maybe was generated by some of these other solutions. So I thought that one had a lot of potential. Now, of course, there's a privacy concern there, right? I mean, as soon as the company says, we work for the government, okay, well, we can't send our code to Anima then. So yeah, if the vice president is going to lock down all the AI, this is definitely something they're not going to let. So it seemed like a good idea. I'm not sure how practical it's going to be in the workplace, but. So with each of these tools, I talk about this symbolic representation of the website. And this is what is going to enable real AI software engineers to exist, is if we can come to a common understanding of what is a symbolic representation of the web, then it's going to be very much easier, much easier to go from text or image to this symbolic representation. And then the symbolic representation to code can be automated. It doesn't need AI. It can just be plug in place. Put each thing in where it goes. So both Google and Apple have published recently about how to do this. They're both very invested in this happening. It's in some ways, it's almost like making a new HTML, a new symbolic representation of the web. This is Apple's paper on the topic. And I just wanted to share with you these examples of sample interactions that a human might give to an AI. And Apple's point here is that none of these are really going to work right now. The only way that this variety of different things is going to work, like call the one on Rainbow Road, call the bottom one, or call the number I see. Like it has to, the language model is going to need to know what the user is actually looking at. And in order to do that, we need to have a symbolic representation of what is currently on screen at any given moment. This is their initial paper to try and do that. Here's the same thing from Google for Android. And it's just looking at how can we use vision models to create a language for a user interface. It can then be used as an intermediate step between text to code or image to code. So that's coming. But again, it's a slow moving train. It's not coming at us that fast. Okay. So one of the warnings I meant to give at the beginning is part of this is not about React. So this is the part that's not even about JavaScript. And what I'm transitioning here, we looked at several tools that claim to do AI engineering, but really are just fancy AI assistants. So if we stop worrying about whether it's AI assisted or software engineering UI or whatever, and just say, what tools can we use to help us? So I wanted to introduce a couple of tools in this space that I use like every day in my job. Comfy UI I don't have to use every day, but I love it. So I do use it every day. But let's look at the first one here. Yeah, LM Studio.
So it's Comfy UI like a component library.
It's sort of. I'll show you
My chef written.
It's for text to image. So it's a component library for language models. For, I guess, vision models. Sorry, vision models, not language models. LM Studio is free. It's free to download, runs on all the operating systems, and it just gives you the ability to chat. Like you go here and you can download any of the models that are available. And so you can search for something like Llama and then find any Llama-based models. So you have to do a little research to figure out what models you want. Each of them are about 6 gigs in size. So you got to be a little selective about what you do. But like I have 2 models here. And so a lot of people talk about using, oh, go ahead.
I'm curious, are these models that you download and then have locally, like, does the performance compare to the hosted models that are out there, like ChatGPT and stuff? Like, would you say that, are you losing anything by using the self-hosted ones?
You can measure what you're losing. With each of these models, see if I can, see the 7V right here? That means it has 7 billion parameters, and speed is a factor of the parameters. So when I load up a 30 billion parameter model in here, it takes like 10 minutes to respond to a question. Can I do a 7 billion? It's immediate. So online, you can leverage more hardware. So maybe they're able to make bigger models run faster so you can get a faster response from APIs. My focus for the presentation was how to do this stuff locally without having APIs, because I didn't want API costs, vendor lock-in, all of these things. Fact is, using APIs, you can get access to newer models that are going to be slightly better. The open source stuff is always a little bit behind. With ChatGPT and Stable Diffusion, they don't release the newest one. You have to use the API for the newest one, but the one right behind that is now released. So I downloaded Minstrel. That is the one after testing a whole bunch of different ones. Minstrel is the one that I like the most. And so now every time like I'm on Reddit and a new model comes out, I can be like, okay, yeah, go ahead and download it. Let's try it out and put the same question into both of them and see what they have to say. Like I downloaded this one, Gorilla. It's supposed to be really good at code. But like every time I ask it a question, it just completely falls apart. Like, sorry, let's load this as the file. So you load up a model and then you can chat with it. It'll take. But yeah, so this Gorilla one, I can't get it to work. I don't know why. It doesn't matter. Mistral does great. Some of the things with LM Studio, I say LM Studio taught me Python. Because somebody asked a question about Dart. They were like, how do I do this thing in Dart? So what is Dart? What is the language that Dart is used for? Flutter, I think. So they're like, I'm in Flutter and I'm doing this thing. And I knew where to find the answer, but the answer was in Python. So I was like, okay, well, in Python, you would do this, but they're in Dart and they don't have this library. And it'd say, oh, well, you've just got to do it the manual way. Here it is in Python. I'm like, okay, can you translate that into Dart? I translated it into Dart. I got back on Slack and was like, hey, is this the answer? And they're like, yeah, that totally works. Thanks. So now I know every language. Like I can't tell the difference between a correct answer and an incorrect answer, but I can generate a lot of answers that are very, very close. So I don't know Python as well as someone who learned it, but I can solve a lot of Python problems or any language problems using, Mistral's my favorite one, but this is all local, so I don't have to worry about privacy concerns or the VP saying you can't use this stuff because it never leaves my machine. So LM Studio, I think there's no code involved. It's just they try to make it super simple. So it's great for people who don't know very much about this stuff. The next step that I took was local GPT. Local GPT. Secure local conversations with your documents. Talk to your documents. This idea fascinated me when I first heard about it. It uses a technology called RAG or RAG, and it allows you to ingest your documents into the model. And well, that's not technically exactly accurate as to how it works. When you make your prompt, it goes and queries your documents for relevant bits, and then it includes those relevant bits in the actual prompt. So it's not actually training the model, but it is including specific information. So earlier, someone mentioned about getting real-time information, and these local models can't query the internet, but you can go to the internet, create the article, put it in your local documents,
With no tokens.
and then it talks about that. Say again?
With no tokens. So you're not getting charged for everything you put in.
Yeah, you can ingest as much as you want. So I'll just look here. What did I do? Look at GPT. All you do is put them in the source documents folder. So like I've fed in like a whole bunch of resumes from other people. I gave it like a bunch of background information about me, including like Wikipedia pages of, about different organizations that I've worked with, all of my writing, all of the job ops that I was applying for. So when I applied to Atlassian, all I did is I took the job op and put it in here. And then I took my resume and put it in here. And then I got her, please write a cover letter from Bishop Zara to Atlassian for the job, senior software engineer outreach. And this is where it went and started pulling from the company's values, their mission statement, integrating that into my cover letter. And no, I still had to review each cover letter before I sent it out the door. And I made changes. It's not perfect. It was way better writing a cover letter than I am. So what am I going to do when I get my new job? I'm immediately going to install local GPT and get every document I can find from the company and load it into there and start asking questions. Is this company profitable? How does this company make money? Like, start asking questions. And I'm going to learn a lot more about the company very quickly. The other kind of cool part, if we can go to VS Code here for a minute. Oh, sorry, it's on the wrong view. Yeah, that's fine. So this is the local GPT doc repo. And this is the file that actually runs the whole thing. And this is all written in Python. Again, I don't know Python. But I asked Mistral, hey, I want this thing to like read aloud its answer when it's done. And the program's written in Python. How do I do that in Python? It just spit out this one line of code. I had to add. Now I know Python. Yay. And yeah, so it reads it. So that was my like one addition to local GPT. And I maybe would, maybe would continue to build upon it, but I have now decided I'm going to switch to Open Web UI for all text-based stuff. Because it has all this great documentation. And you can see that it's just like a web browser. I've got it running here in Docker. And it's basically the same thing as LM Studio. It's running on localhost. And I can download models and put them in there. I haven't put any models into this one yet. This is kind of where I'm going. If I was going to say, you know, what tool should you start with? If you're scared of this stuff, start with LM Studio. If you're not scared of this stuff, go right to Open Web UI. This seems like the best, most well-documented, best future for a project that is based on large language models, RAG, and the ability to run it locally and be extensible. So when new models come out, you can just throw out the old ones, put in your new ones, and you're off and running. That's great. That's for my workflows that involve text to text. Trying to get it to write a cover letter. I want to ask a question about my company. Anything where I'm starting with text and I'm ending with text. Comfy UI is for text to image or image to image. So it doesn't work with language models. It works with vision models. I guess let me pull up their website. Yeah, it's just a GitHub repo. Star Developer just joined their team, so everybody's expecting great things from the future. I can tell you that it's really fun and it's really easy to use. But it does take a little bit of work. It's not perfect. The documentation is not great. That's nice. So let me show you a simple UI model. This was the first one that I built. It's not super easy to use on a touchpad. I usually have an external mouse, so it's hard to be scrolling. But you can see that there are all these nodes. Simply drag out your nodes and put them where they go and then wire them up together. And it kind of looks like a little bit of a hairball at first. And what you need to do, the biggest difficulty for running it, Comfy UI, is that you have to add a bunch of stuff into this models folder. It does not come with any of the models. It's just the modular interface to use them. So then you have to track them down and find them. And here's the checkpoints. These are actual vision models that I use. And SDXL, Base, and Refiner, those are actually made by Stable Diffusion. Those are the kind of XL Stable Diffusion models. And then these are all trained versions of that model, where someone has trained it on additional more images. So I'd like to try out some of those. But like if you want to use control nets, you have to download the control nets and put them in there. Embeddings, I had to find all these. And yeah, LoRa's, these things are really great. I found a whole bunch of them, starting to categorize them. And it's just like Rembrandt. Your lighting is going to be a little more Rembrandt-y if you use this. So in any event, point is you got to put all your models in there and then you get a nice thing. And I would say that this hairball here represents about 3 days of work. It took me about 3 days to get up and running with this. And then my current one, I have like all the settings here, all my LoRa's. Oh, sorry, this is the settings, this is the prompts down here, and all this fun wiring that goes up to this multi-step process that takes the image through.
What are you generating with these?
So let's generate one just so we can see how it works, because we're almost done here. One thing, I put a little noise generator in there, so I got to tell it to generate the noise. Okay, it made some noise. Thank you. And then I have put 2 images down here. Let's see. There's a nice little picture of a house. That was, I think that was generated. And then, yeah, this is my model. I use the Vogue app, Vogue Runway app. I'm sure you guys are all super into fashion. It's okay. Yeah, so it's just a fashion person. I like troll Vogue all the time and download all these like fancy people in fancy clothes. And then we write something about it. Blonde model in a fashion, not leather, stands outside of a modern villa, which is what this is a picture of.
So what we're seeing here is you're actually live prompting and you're wiring it to the different models that you've got installed and getting an answer based on all of them.
Yeah. So here's the queue. We're going to queue it up. And then we can go over here. We can see now it's doing something. It's doing a clip text encode. Cool. And eventually it's going to get, yeah. So this was the image that I fed into it. And I'm doing several different things here. Like I'm using a vision model to describe that image. I'm using a vision model to describe the other image and including those in part of the prompt. Multiple other things. And these are all explained in the examples. But this is the base model. So it's going through and it's going to go through a series. I think I have it set in 50 steps, 40 steps, something like that. So as soon as it gets everything ready, we'll see a progress bar pop up here. And we'll start going through those steps. You don't get any preview along the way, but after the base model finishes, we will get a model of what the base model gave us. I do some color correction on that. And then here, this is a face refiner. So it uses vision model to detect faces, builds a mask around the face, and then runs the refiner on just the face region and puts it back in. And then a final refiner, and then I use 3 different upscalers, AI upscalers, to produce a image of double the resolution. So that's the full process that I have. You can see it's still working a little bit, so we'll give it a chance. Any other questions about it? This is different. So what is this for? Right? This isn't helping me with software engineering. What this helps me with,
The great wardrobe.
this is my website. And making a great wardrobe, sure. But my website, like these images I want to publish on those times. So anytime I need an image for anything, my profile pictures, you could put a picture of yourself in and have it make a better version of you. I don't know if you've seen these on Facebook where the photo looks like it's $1,000 an hour photographer with a full lighting kit and like they went and did scene scouting to figure out where it should be. I mean, it's just too perfect of an image of these people. And it's the profile picture on Facebook. They're using these image generators to generate this. So again, room for failure. Like I'm not a very good photographer. So if I need photography, this is going to make better photography than I can. Yeah, I've set to a lot of steps. I was trying to do some dance stuff earlier today. It's really bad at hands and feet. And so trying to get someone like to jump like a ballerina, it just mangles it. So I've got it set it to really high for steps right now. Let's get in there.
Thing I would love about, like, specifically if we're going to go LLMs and coding, like Copilot, all of them are really nice, and they're trained on so much. It's like, I want to run this local for privacy or whatever reasons. It's like, I really don't need it to know Dart. I really don't need it to know Python. So it's like, I would love to have a model builder that's pare the parameters down.
Just what you need.
Because you're like, when was the last time you really needed help writing a VB? I've been writing a VB.NET file in probably 15 years. So I'm pretty sure asking it a question about VB, I don't really care about that response.
Probably written in Python, so put it that one out, right?
But that was one of the things, and also the reinforcement training. Copilot does this, and I haven't looked into it, but pointing it at your repo and letting it train on your code, so the next component you write goes, hey, I think based on the other 10 things that look like this, you want this. And that's what I want right now. That's what I want today.
Yeah, so Anima gets close. Anima will do what you're talking about, train on your code, and then it'll produce things just like your code. So that, I mean, that gets close. They do have a mixture of experts where they train one on Python, one on Java, one on JavaScript, one on each language, and then they have a router that decides which one gets the answer.
Okay.
So they're starting to try some of that. We can see our image here. The face is not very good. So sad. But that's okay, because that's why we run a face refiner. And it got a little better. Not perfect, but that is a much better face than the original. It looks a little plasticky, I think, or like a render. But it still has the refiner yet to run, and then it'll try and upscale. So yeah, you could just give it 2 images, what you want, or the initial one I built did not use images, just the text prompts. And then I would just describe what I wanted, and it would go and build it. So that's great. Open Web UI for all the text-to-text models. And then Comfy UI seems great for all the text-to-image and image-to-image models, all the vision models. So then one last thing that I kind of wanted just to oh, yeah. Sorry, this didn't make it into the notes. It just bring up a little bit. It's we're about to be done here. Yeah. So synthetic data. This is a paper that Google published just a few months ago about best practices, lessons learned on synthetic data. So synthetic data is where we use language models to generate data to train other language models. And so as you start to use this stuff more and more, you're going to be generating a lot of text or a lot of images. If you then use those images or text to train on, one thing that can happen is that the bad parts get accentuated, become more and more bad. And so I wrote an article about this on my website, synthetic data, where I just summarized their paper and then wrote some commentary and went on to describe some of the benefits of synthetic data, why you want to use it. And then I wrote this tutorial in Python. I don't know Python, but I was able to find enough documentation and ask enough questions that I know that this is actually good code. This is actually really how you make synthetic data with scikit-learn in Python. I can make a tutorial about it, even though I don't know the language. So that's fine. But some of the things, limitations that they point out, yeah, is that bad stuff will continue to get reintegrated. Now I'm taking this and I used my language model to write this article. I used my image model to generate this image. Now, if Google or some other model maker then scans my website and uses my stuff, it's like a honeypot. It's going to accentuate all of the bad stuff out of all of those images. So part of the point that I make in my why section here is that the web used to be this pristine, not pristine, but it had a lot of human generated content. And more of that content now is becoming generated by AIs. And so then we can't use that data as much. So we're in a golden age of data use for these language models that got them as far as they are. But that well is starting to dry up because of the issues around synthetic data. So I do recommend using all of them, but yeah, so we have our final refined version. Face got a little better. Hands look great. Reflection looks good. Yeah, all in all, nice image.
Doesn't look happy to be here though.
Oh, it's a fashion model. Probably starving. So yeah, in conclusion, AI is good at being the missing link. When you don't have a designer, it's a great designer. When you don't have an engineer, it's a great engineer. Whatever you don't have, it will at least be 50% good at that. One thing I wanted to mention is greedy programming. This is one of the critiques that was offered all the way back against SWA, was that it was greedy. A lot of people are using this now and they're testing this 13%, can it do it 13%? And they're saying, yeah, but even when it succeeds, it's greedy. What does that mean, a greedy program? Well, what they're saying is if you use spaces, it very well might just go in and add in its lines using tags. Then you use 2, well, no, it's going to do 4. It's not, if you wrote a function to do exactly what it wants, it's not going to use your function. It's going to write another function to do it. Now you're going to have 2 versions of the same function. Like it's trying to solve its problem and it's going to take the shortest path it can to do that. But that doesn't mean it's going to respect the best practices, the coding standards, or even the style of what's already there. And so, you know, it kind of gets down to this, does bad code matter? Like if it's going to be greedy, you could imagine the synthetic problem where we have it go in and it solves the problem, but it kind of makes the lines all messed up. Well, the next time another one goes in, well, now it's just going to be messed up in a 3rd way and a 4th way and a 5th way. And we're going to get to the point where our code is no longer maintainable if we continue down that path. So does bad code matter? I don't know, maybe if we just turn everything over to the computers and let them always just build everything, then nobody would ever have to look at code again. Maybe it wouldn't matter if it was ugly. But yeah, synthetic data, I mentioned that. And then I've already talked about this symbolic web, but that's where I see the real future of what we're looking at is the symbolic web that Apple and Google are talking about for their phone, where it really is understanding what you're seeing in a structured way. And that can be very easily translated into code. So I see a lot of potential there. That was a lot of talking.
Very good.
Right at 7. Thoughts, questions, comments?
I do think that in more circumstances than you might think that it's not going to respect that you've already written a function that does X. It will write its own. I think that does cause more problems than it might look like at first, because storage space is relatively cheap now, but that will still cause multiple points of failure where if you don't know which version of that function it is, it's going to make you check both of them. And if it keeps making more versions of that same function, then you have to check all of them. It's a maintainability nightmare. You kind of got at that a little bit, but that's especially bad if you're trying to make it with database stuff. Because data duplication is even harder to correct unless you have some function that's like, oh, if this changes, then we have to change all these other things too because of it. That's maintainability is just kind of one of the things I like to prioritize. Partially because I just believe in preservation. But I think that's the end of my thought, actually.
We have a question from Fabio online. Yourself.
Do you want to read it?
Hello.
Please.
Can you guys hear me well?
Yes.
Hello?
Yes.
Oh, sorry about that. Yes. Thank you for the presentation, by the way. Really informative, a lot of great information there, and somewhat eye-opening in some of the tools that you showed, so much stuff that's out there. I guess one of the questions that I had is related to like thinking about today, like what could I take from this to maybe be a better developer? From all the tools that you've experienced and worked with, which ones would be the ones that would be probably the best to focus on or start? kind of an AI journey to become or help you become a better developer right now? It seems like there's so much stuff out there that it's kind of hard to keep track of everything. What would you suggest, I guess, would be kind of good ones to just couple to pick?
And this LM Studio is the easiest. It's the simplest. And for me, this is really on my journey. This is how I started. Is I downloaded LM Studio. That was the first one I got, and I learned a little bit about how to get the different LLMs, how to get the models, and how to download those. And then I just kept it open on my monitor. And then as I was doing my job during the day, I would find myself going to Slack to ask a question, and I'd be like, "Wait, I'm going to ask my model first." And I would see then people asking questions online, and I would just take their question and put it into the model, and the model would answer it, and I'd put the answer back into Slack. You know, I can find the answers faster than they can. And I've noticed what I noticed in the company Slack is over those last few months, the number of questions online just started dropping. People don't need to talk to people anymore unless it's about something like an opinion or something very human. You can just ask an AI and it's going to have a better answer than most humans, at least 50% of them. So that's how I started. And that's where I was super skeptical of all of this stuff until I found that like the chat model, the LLM can really give me answers. And so then coding problems. There are a few like specific things of code that does really good at. Like if you give it like just a loosely structured bunch of text and say, make this into a JSON object. It does a lot of things that for you, you know, that you just, it was be tedious to do. So it gets a lot of the tedium out of there. And then the other big one is troubleshooting. Like instead of taking the error message and putting it into Google and looking for a Stack Overflow article, I take the exact error message and I put it into my language model and I give it some context. And it doesn't give me the answer, but it gives me some ideas of where the answer might be. And oftentimes it'll say it could be A, B, or C. And I'm like, oh, C, I totally didn't think of C. And you're right, it was C, but it's not exactly as they described it. It just told me where to go look. And when I started to notice my own productivity being enhanced in that way, that's when I started to get into this in a more serious way.
Thank you. Yeah, that's great. I'm gonna go check out that LM Studio. I had not seen that before, so looks pretty neat.
Yeah, it's pretty straightforward. Keeps track of all your chats here. Has a nice search thing for the model, so you can find new ones. It has this like playground, which I haven't used. You can run it on a local server. Yeah, here's all the models. So you can kind of keep different models and see which ones, you know, keep it cleaned up. Because like I said, these are all several gigabytes each. So you can't get too many of them. There's one other thing that it has in here, like forget where it is. Maybe it's just in this playground area, but you can have the same prompt and give it to two different models. So you can just kind of see it side by side of like what the different models outputted. So it's kind of a nice comparison tool. And that's basically all it does. It's just basically ChatGPT, but you can run it locally. Oh, and it does give you all this stuff. If I minimize this, all this stuff over here where you can change like what is the system prompt, which is the prompt that is given for every time you type in. It says below is an instruction. Well, you could change what the base level prompt is, and like temperature controls like how creative it gets. And you can tell it like, give me a short response or a long response. And then there's all these other settings in here that you can mess with. I don't mess with that stuff too much, but it's just nice to have if I did start down that path. The only complaint I have with this program is that there's no code. I like coding. I like writing code. I get to writing code for this.
All right, any other questions online? Going once. Cool. I am going to stop the recording here. I'm not going to close the Zoom just yet, so we can hang out and chat for a little bit longer. We have the space for about 20 more minutes before we get booted out to the curb. So thank you everyone for coming. Next month, we have Dan here is going to be talking Web3 and how it's not crypto bros. Very interesting talk. I think we've all heard a lot about Web3 and what it is and isn't. Is I can't even answer that question, and I don't really want to at the moment. So, anyway, thanks everyone for coming, and have a great night.